Cool. Hey, everyone. So today I'm presenting this paper that came out of DeepMind in April called Long-Form Factuality in Large Language Models. It's a collaboration between DeepMind, Stanford, and the University of Illinois, Urbana-Champaign. It's a really cool paper, and I'll get into it, but I thought I would start with like why I chose this paper. So a topic that really interests me personally in research is this idea of automatically collecting and curating data to train LLMs. So using LLMs to train LLMs, to train themselves, to get smarter, either in a specific domain or in or overall. And one of the main challenges towards that goal is curating the data set, in my opinion, because you can't curate a data set at the scale of the pre-training set of large language models by hand. It would just be like way too costly. And every time there was new information, it would just be way too costly. So if you want to curate a data set, and there's a lot of evidence to suggest that the higher quality the data, the better the language model. So as an example, if you look at the split of how they train large language models, like the GPTs and Claude and all of that, I don't know if Claude has it out, but definitely for the GPTs and a lot of the Google models, they do tell you what the split is that they used. There's the Common Crawl data set, which is where they just scrape the internet, essentially, like the entire internet, and they use that, create a data set out of that. But then they have other data sets that they use, like Wikipedia, and there's one called Book 1, Book 2, I think there's also Book 3, and those are just English books that are of high repute, like a large number of them. And actually, they use Wikipedia like 4 times as much as they use Common Crawl when they're training this data set. And they use those book data sets as well a lot more than they use Common Crawl. So the quality of the data that you feed into these models is important. Otherwise, they would just use the Common Crawl data set because it's actually way larger than the other ones that I talked to you about, because it's a very large part of the internet. So data set quality is important, but if we want to continue to scale data set quality in a way that's not too costly, and also keep the quality scale the data set and also keep the quality high, I think we're going to need to find like automatic curation methods. So like one sub problem of that is judging the factuality of the data. And that's what this paper is about. So it's about like long form text. You get long form text and you want to judge its factuality. How do you do that? Now, that's not actually the problem. The problem that they're addressing here isn't with respect to new data. It's actually with respect to large language models. So the specific problem that's being addressed here is, say that you have a large language model and you ask it a question and it gives you an answer which is a couple of paragraphs. And then you want to use that answer as like a source of knowledge for something. Then probably one of the most important things is that the facts in that piece of text that's been generated are correct. So the question that they're trying to address here is like, can we determine how factually correct a language model is on average? So maybe like GPT is much more factually correct than Claude. So if that's something important, like if you're not writing literature with a language model, but instead you're writing like a news article, news article isn't a great example. If you're asking it for references, like on a person, if you want to find out information about something, and you're using that as your only source of knowledge, then how would you, you would like to know how factual it was. So this is what this paper is about. How do we measure factuality? Which LLMs have the best, tend to produce the best long format factual responses? So I think it's a really cool paper. Unfortunately, it doesn't it doesn't touch upon like the main problem, or that I thought like the most interesting part of the whole problem for me that I was hoping that they would address, which is verification. So say you look at multiple different sources and they have conflicting information, like how do you choose what's correct and what's not correct? But they actually, the way that they've set up this problem, they don't even get into the verification doesn't really come up because they're basically asking for different information when they look at different sources. Or at least they don't mention it anywhere here. But I still think this is a really good work paper because it shows us like, I think it's the first step towards having like, towards creating fact-checking systems for us that we can use to evaluate LLMs, but also possibly even just as a way of automatically fact-checking ourselves, which would be great. You know, like if you could run, say you get an article from the New York Times, if you could run it through fact checker. In fact, that actually exists. I think there's a news website called like Factual or something like that, where they grade articles based on factuality and bias and stuff like that, which I think is really cool. But anyway, really interested in this sphere. And let's jump straight into this paper. So, and maybe as like a context for this paper, because I have some questions that I thought I would ask throughout, is just think all of the questions kind of center around this idea of like, what would be acceptable to you if you were using this tool or this LLM as a fact-checking tool? Like, what would be acceptable to you? But so the paper itself has 3 contributions. The first one in section 2 is they create a data set they call long fact. And what long fact is it's a data set of prompts that span many, many different topics like architecture, engineering. Let me show you the topics, right? Oh, I probably should sidebar. I'll show you the topics real quick. They are, this paper is really long. Here are the topics. So you can see like the data set spans 38 topics. And I was like, why 38? That's such a random number. But I think it's because it's probably pretty hard to come up with other ones that aren't like really niche. Because they already have some niche ones like virology or business ethics is niche. But you know, things that you really don't hear about talked about that much. But anyway, these are the topics. So long fact, the first contribution is creating this large data set of prompts. And then what they can do with these prompts is ask an LLM to provide an answer, where the prompts themselves are asking for information about the topic. So the responses should contain a lot of facts. So the first thing that they do is they create this data set. And then the second thing that they do, long fact, and the reason why well, actually, let me go back. The reason why this data set is novel is because up to now, there's only been one data set, at least based on the related work in this paper, that there's only been one data set that looks at long format text generation in terms of factuality, and it only looks at a single topic, which is like biographies of famous people, I think. So long fact, it makes it creates a data set that's over many different topics. And so the second innovation of this paper is what this system they call SAFE. Let's go up here because they search augmented factuality evaluator. Sorry, evaluator. SAFE. And so the reason why they create this method SAFE is because, well, as I said before, the only other data set that exists is for long format text is on a single topic. And it's on a single topic because the way that they evaluated LLMs in terms of this single topic was that they had human annotators annotate the factuality of specific facts in long format text. And that's both costly and time consuming. So one of the big things of this paper is like, okay, how can we scale evaluation of factuality and it still be correct? And so they suggest this method called SAFE, which is basically an agent that uses the internet to fact check. But we'll go back to that. And so they've created this data set which spans multiple topics, and then they propose a new, more scalable evaluation method. And then the last thing that they do in this paper is they introduce a new metric called F1 at K, where they basically create a metric that measures like factuality, but I think also kind of in terms of usefulness. At least that's how I would intuitively think of it. And they call it F1 at K, and we'll get back to that. So they create a new data set, they create an evaluation method, and then they create a metric to evaluate models. So interestingly enough, this entire paper is just about experiment design, really. There's no method that proposes like a new architecture, or the problem that this paper is solving is actually improving the experiment design for a specific problem, which is pretty cool. I like that. That is a paper. Okay. Let's go through this paper with those things in mind. I have the things that I have in purple are things that I was like, I wanted to mention. So one thing that they say in the introduction is language models often produce factual errors in which a claim contradicts established ground truth knowledge. For example, models may respond with incorrect information about the established facts, such as dates, statistics, or even a celebrity's occupation. I know this is small, but I was really wondering if this is like a tongue-in-cheek joke, like, because you'd think that the last thing that you would mention in this list is the most important. So I was wondering if they were putting this in to be funny or not. If anyone read it and they laughed, let me know when they read this, or if they didn't think of that at all. So I just wanted to point that out because I thought it was funny. Funny that I think that they're making a joke, but I'm not sure. Okay. And then we'll get back to these numbers here. Let's just jump into the different three parts of the paper. So the first part is this long fact. And one thing that they say here is we focus, for long fact, the data set they created, we focus on factuality and factual errors, not hallucinations, as our proposed evaluation method focuses on determine whether a response is factual with respect to external established knowledge, factuality, rather than whether the response is consistent with the model's internal knowledge. So they are pointing out like a kind of specific case, but it could be that the model is factual but making it up because it doesn't actually know what it's saying. It's just guessing the correct answer. But it's not, they're saying here, we don't care if it's guessing the correct answer, we just care if it's correct or not. Anyway, so for long fact, what they did is they came up with 38 topics, and then they created like a prompt to ask GPT-4 to develop 30 unique prompts per topic that are asking for information about that topic. And that created a data set with 1,400 prompts in it. As you can see here, like FactScore is the only other data set that has long form response types, and it's only on one topic, whereas this is 38. There's not a lot more to this part of the paper, but it's definitely a contribution because it is helping to establish like a more rigorous experiment design for this topic of long form factuality. So then we move on to SAFE. Yeah. Then we move on. Let's see. Yeah. Okay. Then we move on to SAFE. So this is how this is what this is how they evaluate LLMs, because at the end of the day, you want to know how factual an LLM is, but we need some kind of oracle that tells us whether the facts that come out of the LLM are correct or not. In the past, that oracle was a human, and now they're proposing SAFE. Now, SAFE, what it does is it performs 3 steps, which it shows down here. First, well, should I say that first, or should I say the purple thing first? I'll say what it does first. So first, what it does is, so you give SAFE, this system, this agent essentially, a long format piece of text. It splits the long format into individual self-contained facts. Then it determines whether each fact is relevant to answering. Actually, let's go up to here. It's a lot easier to see in the diagram. They have good diagrams of this. So here could be an example. This is SAFE, what it does. So your prompt is like, what is the Eiffel Tower? And the response is, the Eiffel Tower is a tower in Paris. It opened in the 20th century. The Nile River is in Egypt. So it splits the long format into individual facts, which is the Eiffel Tower is a tower. The Eiffel Tower is in Paris. It opened in the 20th century, and the Nile River is in Egypt. And then it revises them to be self-contained. This was a step that I was like, I wouldn't have thought, like, that's not an obvious step that probably, but definitely should be there when you're doing this, where they take the pronoun it and they replace it with the Eiffel Tower. Then they have a stage which checks relevancy of each of the individual facts. And so you can see that the last fact isn't relevant. So they don't even, what you'll see later, they don't actually, yeah, go ahead.
Hi, Peter. Sorry, can you hear me?
Yeah.
Yeah, so I had a question about the length of the response. Maybe I've overlooked it, but they haven't talked about the length, and also the length of the split responses. Does that matter? Would that have any effect on the relevance?
Good question. So the length of the responses are paragraphs. So it's multiple paragraphs usually. You can, to give you an idea of what they did in the evaluation, is they have this metric called F1 at K, where K is the number of facts they would like to see in the response. And they did 2, 64 and 178. So 178 is a random number. But the idea, so the paragraphs that that were asked to be generated should probably contain at least, in one case, 64 facts, or in another 178. So that's pretty long. But I do know that when they're separated into facts, we can, I think there's examples down here where you can see exactly. Sorry, give me a second. Maybe here? No. No, still prompts. No. Yeah. So here's the prompt, or here's the question, sorry. And then here's the model response, which is 3 paragraphs. And then here's like a individual fact to give you an idea of what the size of these things. So yeah, the individual facts are a single sentence. Okay. So then what SAFE does is it will, as a third step, it will take the, will tell you whether a fact is relevant to the prompt or not. And if it is relevant, then it rates the factuality of the fact using a Google search, where it will use an agent to perform a set of queries on Google and receive information. It does 5 queries, and for each query, it receives 3 sources of information. And then it will, like, information from 3 sources of information, and then it aggregates those to decide whether the fact is supported or not. So yeah, it does actually look at multiple sources, but again, there's no talk about how it verifies, like if there's conflicting information, how it verifies what to pay attention to. And also, when I was looking at what the Google query responses kind of look like, they're single sentences usually that are not like they're not long enough, I think, it's probably very unlikely that you'll get the case where even though you're looking at 3 sources, they're talking about the same thing and they could be conflicting. So, and I think that's kind of by design, because this is an academic paper where you probably don't want to go into that level of depth on that specific problem. But anyway, so they rate SAFE rates each of the facts that are relevant based on whether they're supported or not by Google. So you can see 2 are supported and 1 is not. Yeah, go ahead, Damien.
So I was wondering, because here they decompose this initial response, which is like the Eiffel Tower is a tower in Paris, into 2 facts. So like the first one is that it's a tower, and then the one is that it's in Paris. And like I was wondering, do they show what the prompt is for that decomposition? For that?
Yeah. One thing, maybe something I forgot to mention is that also the code for all of this is on the GitHub repo, which is shown here. And that's everything in this paper. So this is something DeepMind tends to do. They don't release all their data sets usually, but they do tend to release a lot of code. So yeah, all of that's there. Let's see, where's the prompt? Yeah, see prompt template used in SAFE to split sentences into individual facts. So here's the prompt that they used. Okay, let's go back. And so the output of SAFE is a set of 3 numbers for each long format response, which is how many supported facts there are, how many not supported facts are, and how many irrelevant facts there are. Yeah, go ahead, Anna.
Hi, thanks. Sorry, Peter, I have another question. Does it matter where the response is embedded within the text? Because in every kind of paragraph, it starts with a fact. And the second paragraph also starts with a fact. But I haven't really where it. Does it matter if it's embedded like at the start of the text or in the middle or in the end? Again, I haven't found that in the paper. Maybe I'll have looked at it.
Yeah, that's a good. So one of the things that, oh, sorry, I don't know if I just interrupted you. Okay. So one of the things that they point out as a limitation of this paper is the fact that they use LLMs as part of SAFE to do the evaluation. And so it could be the case, as you're pointing out, that the model isn't picking up all the facts in the long format response. They are making that assumption as part of this method. And they don't have anything to check whether it is or not. So that might have been something good to do as part of this paper. Who knows? Maybe a reviewer will ask them to do that. But yeah, it is an assumption of the paper that the LLM they're using in SAFE can extract all of the like the factoids from the long format, no matter where they are or how they are expressed. Okay, so we were talking about SAFE. And here is my first question for you all. Let's go down here. Oh, so one of the more philosophical or conceptual slants of this paper is that we agree with the idea that long format responses should be evaluated at the granularity of individual facts. You know, that makes sense to me, but I just wanted to point it out as like, it's more of like a conceptual choice than anything else, to see if anyone had any thoughts about that, like whether you should think about it as an overall piece or if you should just look at it at the level of individual facts. I definitely think it's easier to evaluate at the level of individual facts than if you were to look at it as a long format piece. Okay. And then I've explained, okay. Let's go on to talk about how they evaluated their evaluation method. So the idea is that they want to propose an evaluation method which is more scalable than using humans. But that means the method should be at least as accurate as humans are. Right. And so what they found is that when they actually took a prior work, that the one where the author only created long format pieces of text for a single topic, where there's like 16,000 annotations created by humans, and they used their method, and they took the human annotations and then they compared them. So they didn't do it across the entire data set, they just did it for this one topic. But they found on this topic that the model had a 72% agreement with the human annotators. And then what they did after that is they took 100 random samples where they disagree. So from this 4,000 here, these 4,000, just 100 of them. And the researchers, what they did is they did some old school research where they looked at the fact, then they went on Google themselves and tried to verify it or not to see whether it was correct. And what they found was that in 76% of the cases, like in 76 examples, it was actually their model that was correct and that the human was incorrect. So one of my questions was like, so if you were to use SAFE, if you had a piece of text that you wanted to verify with factuality of, and you knew that it was 72% like a human, and in 76% of the cases where it's not like a human, that it was correct, and the human was incorrect, how much would you trust SAFE as a piece of software? Yeah, go ahead, Damien.
I think I trust it because even now when I use something like ChatGPT or Perplexity, a lot of the time I do my own verification afterwards. So I wouldn't trust it to like 100% that I could release this system and be happy with its results. For example, if I was doing my own research and I used SAFE to verify the facts, but it definitely give me higher confidence than just blindly relying on LLMs.
Yeah, so I guess right now we couldn't use it as the verification system, but we could use it as a useful one.
Yeah.
Because, yeah, go ahead, Lewis.
Sorry, I didn't mean to sort of interject there. I just wanted to put a personal anecdote in there. So I actually did something similar to this probably about a year ago now, where I created a tool for writing newspaper articles, and specifically for our company, we have a lot of brands, probably over 100 brands in the UK. So it's Reach PLC for those interested. So like the Mirror, OK Magazine, the MEN, the Express, etc. Yeah, I did build a system. So it was a LangChain agent, and essentially it would take a chunk of text. It would go through an LLM to suggest kind of similarly here that questions about that chunk of text to verify it, and then it would also give the journalist the opportunity to write their own questions if they wanted to. And then it was a DuckDuckGo like internet search agent and an LLM wrapper on that. So it would pose that question, it would search DuckDuckGo because it was free at the time, and then it would pass the result and come up with like a Boolean true or false. And I thought it was, it performed relatively well. A lot of latency, obviously, with agentic solutions in production. So it's kind of in the end, it wasn't all that useful. But yeah, I think even if it isn't sort of, yeah, I said you can't sort of rely on it completely. It could flag to somebody who's interested in that, like, hey, you probably need to fact check this, or you need to look into it a bit more. So, but yeah, it's interesting. Yeah, it's the first time I'm coming across this. So interesting.
Yeah, I think it is really cool. Yeah, and you just pointed out kind of like I could totally one of the reasons why I think I asked this question. I could totally see in the future that a huge amount of like a lot of underlying systems will probably have some kind of, hopefully have some kind of factuality checker, because we've already started using LLMs as sources of truth, and like it seems ethical to have a factuality checker as part of that system. But then if the factuality checker isn't perfect, how much can we trust it? Like if there's no human in the loop for so many of the things that we do in the future, and we're like using LLMs as our sources of information, is that all right? I have this like kind of conceptual question in my head constantly of like, how accurate do these things have to be? Because we know they make mistakes, but how accurate do they have to be? And then especially, and the thing that I think a lot of people evaluating machine learning forget, like techniques, is that especially in the context that humans are also make mistakes and aren't always correct. Because sometimes I feel like we say that the machine learning has to be 100% correct when the person is like 60% correct. But anyway, another interesting thing that they point out about SAFE is that it's way cheaper than using a human evaluator. So instead of costing $4, it costs 19 cents. As they do also point out, as you said, Lewis, that there's a lot of latency involved. But I was thinking, for anyone who's looking for a startup idea, creating like a factuality checker probably would be a really good startup, because it costs 19 cents to verify a fact, but I bet there's a lot of repetition. So it'd probably be one of those things where like as more people used it, there would be economies of scale, because you could just use a lookup database to find like a fact that's already been verified. And then the cost would reduce even more. So I wouldn't be surprised if there is a startup that does that. Yeah, go ahead, Damien.
It's kind of going back to this paper. I was I had a thought like it would be a lot more richer if there was like a confidence score somewhere. Let's say like I'm not too sure about this, or there's like 20% chance that this is wrong, and a method to flag that. If that was there, like it would be amazing, because at that point you can get humans in the loop, and this process would become really accurate, I think.
Yeah, that's a good point. I think there's a ton of, so usually the way that you measure accuracy when it's short format is by performing multiple calls to the model, and then seeing how much they agree with each other. And that's pretty agreed upon in academia, that that's a good way of doing this. At least that's my impression. But it involves doing multiple calls to the model, which when you have systems like agentic systems that are already doing a lot of calls, can really just increase the cost. So I think that we're waiting for like a couple of years from now, where hopefully it's even cheaper to call models and faster to call models, so that we can start having these uncertainty estimates available. But we already kind of know how to estimate uncertainty. I definitely think that's a good point, though, Damien. Okay, so the last part of this paper is this F1 at K. So this part of the paper was a little bit hand wavy for me, but I also don't think that it was, I don't think it's incorrect. I'm like, I wonder, I feel like there's some missing explanation into why this is what they did. So they had to come up with a metric where they could take the numbers that came out of SAFE, and then also measure like the factuality in a single number. And they decided to use this F1 at K. And so F1 at K, they create, you need, for F1 score, you need to know the precision and recall. And the precision, as they call it here, is where it's the number of supported facts divided by the number of supported facts plus non-supported facts. That makes sense. It's like supported means correct and not supported means incorrect. That's classic precision. But for recall, I don't exactly see where they came up with this, but they have this, for recall, they have the way that they calculate recall is they say, we assume that the user wants to have a certain number of facts in their long format text. That number is k. So we will take the number of actually supported facts divided by k in order to calculate recall. And then if the number of supported facts is more than the number of facts that are asked for, then just give it a value of 1, similar to recall, which can only have a maximum value of 1. One thing I noticed in all of this, I was like, there's no evaluation. The evaluations do not take into account at all the irrelevant facts in the paper. And I actually think that's kind of related to factuality, because if you have a ton of irrelevant information, you might think it's relevant. So I was thinking maybe they should also include the irrelevant number in their metric. Anyway, that's the metric they use. So precision divided by recall. I think that's it. You're not penalized for having too many facts. You're penalized for having too little facts. Yeah. The question for the recording was also they assume there's no such thing as too many facts, right? So this is how they calculate F1 at K, and here are the results. So F1 at 64, which means where they want to see 64 facts in the long format text that are supported. Essentially, you can see GPT-4 Turbo is the best, and then Gemini Ultra. One weird result that they flag is that they see that Claude Sonnet has a better performance than Claude Opus, even though it's a smaller model. But in general, it's like GPT-4 is the best. And it's these 3 models, these 4, except for Claude Opus, like the 3 top models are also the largest models in their family. We can look at like this table with results, and it's always that like the largest model has the best performance, except for Claude Sonnet has better performance than Claude Opus. Found it a little bit surprising because in my work, I found that Claude Opus is quite good, but I think that's maybe because it's better at following instructions, and this this work isn't about following instructions. Yeah, those are the results. I don't have anything. Let's see, is there anything important here? Yeah, the results, those are the results, nothing more to flag. And then they point out what we discussed before about the limitations, which is with respect to generating long fact and also safe. A language model that cannot follow instructions may generate prompts that are not without the given topic or that do not solicit long form responses. But that also means like if the language model doesn't follow the prompt, or it isn't able to follow the prompt, that kind of would make the generation of long fact worse because it was generated using an LLM, and also it would make safe worse because the individual steps weren't being performed as they should. So that's the main limitation that they highlight. Go ahead, Anna.
Hi, Peter. I was wondering, they haven't about the fact versus opinion. So I don't think they touched upon this, but they tested the system, how it would react. If it's trained on the facts, how would it react on the opinionated word? For example, Eiffel Tower is beautiful. Will they treat it as a fact, whereas it's in fact an opinion?
Yeah, I think that stems back to your previous question about like how good is the model at distinguishing facts from other pieces of information in the text, and probably that would be a good experiment to do. Let's just check. Like maybe it's in the appendix. I doubt it is, but I'm just looking at the. No. Yeah, okay, they didn't do an experiment to that effect, but it would be good to do, especially because there's a couple of questions about its ability to, the ability of safe to extract facts. Then another weakness of the method is that Google search may not easily find information about some fact or may lack profundity in expert level domains. So profundity means like a deep set, like a good amount of knowledge. So yeah, another big assumption of this method is that of safe is that you can use Google to verify. So if Google says if something's supported by Google search, then it's true, which may not particularly be the case. And that's actually where I was like, oh, I really wish that they had something, although I understand why they don't. I don't think they need it for this paper, but like on verifying facts, given the information that's available to them. Yeah. And then they point out that for the metric that they've created, there's an opportunity for our metric to be gained by repeating a supported fact. So you could say the same fact 60 times, then you'd get a high score. So those are some of the limitations. And then they talk about some future work in the conclusion, which is we've talked the thing I wanted to say about this thing in purple we've talked about, so I won't say anything. But they say long-form factuality, they could maybe improve a language model's long-form factuality via better pre-training and fine-tuning, or by augmenting them with external tool use. I was like, this could be, so like, what if you use SAFE, like I was saying, to help curate the data set that you pre-train the model on? That would be an interesting, although maybe like way too expensive thing to do at this point. But yeah, it would be really interesting if they augmented the training by performing factuality checks on the information that they provide the model with. It also got me thinking about, so we've just been talking about factuality, but how could you do something similar for something else, like, like politeness? How could you create a check for politeness? Because that's something that's a lot less objective and kind of like based on culture and context. So in a way, factuality is probably one of the easier things to measure, whereas other things that we care about in terms of how language models generate text would probably be harder. But yeah, that's all I had to say about this paper, and that's what I wanted to go through. So I'll stop here and see if anyone has any questions or things they want to talk about as well. Yeah, go ahead, Lewis.
Yeah, sure. So the main thing that sort of popped into my head listening to this is about the sort of timeliness of facts. So even if you kind of verify at the point of training, and this is obviously a well-known sort of flaw of LLMs, that they do go out of date quite quickly. So something that may be a fact. So, who is the Queen of England for a very long time would always say, oh, sorry, who's the monarch of England? Would say the Queen. Even though it's king, that's like a classic one. And obviously, like RAG systems have kind of come in to, that can provide more timely information at the point of inference, such that the kind of foundational model doesn't need to be as factful as it definitely helps, but yeah, with that system, then obviously it kind of becomes less of a factor. So yeah, it's just think about how useful this might actually be in the grand scheme of things, right? Like, it is useful, but still it's very limited still if, unless you're doing regular retrainings or whatever.
Yeah, that's a good point. Actually, you made me think, imagine if you had access to the data where you didn't have like only the updated facts, but like when they changed. And so you had like the fact that changed over time on a specific topic. That would be a really cool training set to have access to.
Yeah, I had a thought, and I went to a hackathon with UCL quite a while ago now, and it was about sort of transforming the newsroom, and I didn't quite get to like a proper architecture, but I did think like if you could use like a graph neural network to like look over like a social media kind of context for facts, and and try and emulate the intelligence of like a journalist, such that you could have some kind of system of fact checking based on sources, like the reputation of a source, for example, and its following and things like that. And maybe you'd infer something useful. I actually haven't touched any of this, and I haven't really looked at the literature. Maybe that it exists, but I thought it was interesting, and maybe a different way of like factfulness that is more real time than an LLM that's trained on like a historical corpus. But yeah, something to look into potentially.
Yeah, for sure. I think it would be great if we had like a trustworthiness score for every source that was like maybe just automatically opened when you open the page. That'd be amazing. Cool. Well, if there's no more questions, thanks everyone for coming today, and have a good weekend, and we'll see you all next week.
Thanks, Peter.
Thanks, Peter. Good job.
Yeah.
Yes, thanks.